This is the solution video for problem set 4, problem 3. And part A is basically a Boolean proof where I'm trying to prove that expression f equals expression g. And before I start this problem, the most important thing I want to do is try to get a feel for what I'm going to need to do. And so here I'm going to start is kind of just try to notice what variables are kind of repeated multiple times and what variables I've got variables and complements like the c and the c bar. I'm going to keep an eye out for when I can use no name or consensus with the c and the c bar. And here I've got this a or b, and I kind of think about like what would I do straightforward if I wasn't really thinking like really hard about this. I mostly just distribute this whole thing out and then try to cancel terms. But the thing I notice is that I'm going to have like a b with a b here, and I have an a with an a eventually, and basically that's going to be result to idempotence, and then probably so basically I'm just going to be canceling things using weaker terms. So rather than do lots of distributions, what I want to first focus on is try to figure out ways I can use absorption, no name, or consensus to start breaking this stuff down. So I'm going to probably have to do one distribution because there's nothing I can do really in this form. So I'll probably distribute this one because this one has the most terms in common with the others. And I'll start there, and then I need to see where I'm going. So I need a BC bar, so that's probably going to come from there. And then I'm going to need the BD, so one of these, either this B or this B is going to mesh with that, and then I'm going to have an AC, so either these two will mesh or somehow those two will mesh. I'm going to have a lot of duplicate terms, it looks like. So that's kind of what I noticed to start. And let's try to solve this. I actually have solved this before, so we'll see how this goes. So, I'm going to basically distribute this entire chunk. I'm going to treat this entire sum term, product term, as a single term as I distribute this in. So this will be A, B or C, A or C bar or D, or B, B or C, A or C bar or D. And so that's one distribution. And now it's kind of hard to see what I'm doing. I'm not really a fan of this product of sums format, so I'm going to try to take the dual really quick just as a side note. So side note, I'm going to take the dual of this side and see if I notice anything. So A or BC or A, C bar, or D, and then I'm going to be having that multiplied with B or BC or A, C bar, or D. Well, I've got those two together and that, which that's really easy for me to see that that's absorption. So I'm going to get rid of those. So I'm going to have reduced to, so I'm going to kind of absorb these, and so I can do that in this domain, so I'm going to absorb that. So this is going to become A, B, or C, or B, A, or C bar, or D. And that is absorb times 2. Now let's think. So I want to, do I just go straight ahead and just plow through to distribution? I'm going to get two ABs. There's really no great way to pull that out, so I'm going to do that. I think I'm just going to have to do my two distributions at this point. So I'm going to have AB, or AC, or AB, or BC bar, or BD. I'll keep these in order. So that's distribution times 2. So I've got my B, C bar, my BD. So I've got this and this done. And I've got my AC. So I'm going to want to get rid of this AB. And it looks like I'm going to probably have to use consensus to do that, because I've got C in its complement. And so first let's do idempotence to get rid of the AB. So AC, or AB, or BC bar, or BD. So that was idempotence. Just once, do that. Get rid of that these identical terms. And then here I've got my C bar and C, and it's matched with AB. AB, perfect, that's consensus. In nice easy form. So I'm going to end up with BC bar, or BD, or AC, and that is consensus. And just pushing through, let's look at B, where essentially I'm going to draw K-maps for F and G. I need to circle the loops for each sum or product term, and I need to determine if the two expressions are equivalent. And how do I know? So, it shouldn't be too bad. So I'll draw one K-map for F, and I shall draw one K-map for G. And what I'm going to look for to see if all the they share all the same ones and zeros in common. So since this is in product of sums form and this is in sum of products form, I'll need to work with the zeros in this one and the ones in this one. So A or B. That would be, well, let me label my K-map first. Way to get ahead of yourself, Jeff. So 1, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 0, CD, AB. So this is when A bar and B bar are both 0. Or A and B are both 0, is when this is 0. So this is 0, 0, 0, 0. So that's one loop. B or C. So that's going to be when B is 0 and C is 0. So that's going to be 0 and 0. 0 and 0. So this is B or C. This one is A or B. And now I need to get rid of, what else? I got this A, C bar, or D. So that's going to be when A is 0, C is 1, D is 0. Sorry, pull that down. So I need to find this loop. The A or C bar is 0. So this is when A is 0, C bar is 1, and D is 0. So A is 0 is here. C is 1 is going to be over here. And D is 0 will be this. So it's going to be A is 0, C is 1, D is 0. Will be this loop here. So this is A or C bar or D. And I'll fill the rest of this in with 1s. And now G will be B, C bar. So when B is 1 and C is 0, so I get these 1s here. And then I've got BD. And so that's when B is 1, D is 1. So B is 1 and D is 1. So that's this. So draw my two loops. Keep forgetting to draw the loops. So this is BC bar. This is BD. And then this is AC. So A is 1, C is 1, so that's over here. So that's this loop, like that. AC 0, 0, 0, 0, 0. And what does that finish with? So I need to say, are these two equivalent? And to answer that, F and G are equivalent because all cells are identical. That's really all I need to say, because all the 1s are the same and all the 0s are the same. And that concludes problem 3.